Okay, so 7.1 and 7.2. First thing, we're going to graph quadratics in the form y equals ax squared, and then we're going to graph quadratics in the form y equals ax squared plus c. So we're going to identify a and c today and see how they affect our graphs. For what I need you to do, after you get your learning goals down, I need you to find out what standard form of a quadratic is. Okay, standard form of a quadratic. We've talked about it. Some of you may already know it, but it's in the form y equals something. I want you to figure that out right now. If you don't know, can't look back in your notes, find a book and look in that. A little less blurry. So if you need a textbook, grab one now. Make sure it's an algebra one for the standard form. What is it? Yes, Abby? Ax squared plus bx plus c. Okay? Where a, b, and c are all rational numbers, okay? So, or real numbers. X squared and x, those are our variables, and y is obviously a variable. So, what are we missing today? What is not shown in these? Declan? B. So, B be the thing that makes graphing tough. A and C do not. B be a problem when you're graphing. B also be a problem when you're trying to solve equations. B messes everything up. Makes it tougher. A and C, no problem. Okay? Everyone read the comic? Amazing fun?
It was really funny.
I know. Hilarious. All right, moving on. All right.
Hey, I didn't get to read it.
Sorry, man. Took too much time. You're talking too much earlier. All right, everyone looking at number 1. What is A? Logan, what's A? 1. Okay. Rylan, what's B? 0. Yes, we're adding 0 x's. And Sam, what's C? 0. We're adding nothing out there. So really you have 1x squared. Okay. Now, if we're going to graph this, how could we make a table of values for y equals x squared? We just put the x squared in there. How could we make a table? How do we start that? Declan?
Could you do -2, -1, 0, 1, 2?
You could just pick whatever values for x you want, right? Now, the key, though, is when you're graphing a quadratic, it's important to note that quadratics graphs look like this. They are called parabolas. Okay? And we really want to make sure when we're graphing, we have the tip of that parabola, which we call the vertex. We want to see that tip. Okay, that's a vertex, and that's a vertex. So if you're taking notes, those are good things to add to your notes. Those vertices, or the vertex, one of these vertices, either this one or this one of the vertex is called a maximum, and one of them is called a minimum. Or, excuse me, one's called a maximum, the other one's called a minimum. Which one's a minimum and which one's a maximum? Tell your neighbor. Darren, which one's this? What do you think? Maximum. How come?
Because it's like that's the highest it could ever be on that graph.
Good. That's the highest point it could ever be on that graph. It's a good way of putting it. This is a minimum. It's the lowest it could be on this graph. And when we're doing story problems about graphing quadratics, we usually reference maximum and minimum, and we're really talking about the vertex. Okay? Maximum value, maximum distance, minimum time, all those things, they're referencing the vertex. Okay. Now we're going to find out when parabolas open up and down today. That's going to be an important piece. So it would be nice if we could figure out where that vertex is. Notice I've labeled a point on here, vertex, for you, because we want to put the vertex right there in the middle. And then the other thing that we know is there's a line that runs right through the middle of this graph. And that line right there is called an axis of symmetry. That line is called an axis of symmetry. Okay? Tell your neighbor what symmetry means and why we call that the axis of symmetry. Hey, someone tell me. Axis of symmetry. Yeah? Good, yeah, it's like where it's exactly the same on both sides, kind of like a butterfly, yes. Okay, this part of the graph is symmetrical to this. This point of the graph would correspond to that point. You know, if this was a better parabola, it would be the same distance away. Okay, so it's an axis of symmetry. So if we get the vertex and we plot one side, we should be able to figure out the other side pretty easy. The goal is to find that vertex. Now I'm going to tell you that the equation for the axis of symmetry is x equals, because it's a line that only crosses the x-axis. Equation for that axis of symmetry is x equals opposite of b, or negative b, the way we read that is opposite of b over 2a. Negative b over 2a. That tells us the equation for the axis of symmetry. And keep in mind that your vertex is a coordinate. It's an xy coordinate. This equation for the axis of symmetry also tells us one of these two coordinates, one of these 2 points. Which value does it tell us? It tells us x. So when we find this, we also find this. It's like a 2-for-1 deal, dude. Good deal. Okay, so this formula is going to be a big deal. Axis of symmetry is equal to the opposite of b over 2a. It helps us to figure out where to start our graph. So if I'm looking at this, after I identify a, b, and c, the next thing I am doing is figuring out the axis of symmetry using x equals opposite of b over 2a. So I want everyone to figure out the axis of symmetry. Okay, so I'm going to put the negative. I'm going to put where b would be, parentheses, and I'm going to put the 2, and then put parentheses where a would be. What is b? 0. We always use the formula opposite of b over 2a. So 0 over 2 times 1, 0 divided by anything is what? 0. Does it matter if it's negative 0? No, there's no such thing. In fact, 0 divided by anything is 0. And take it this way. Let's say I have 2 of you, like Nathan and Sam, and I have nothing to share with you. But I'm going to share my nothing with both of you. Dude, how much do each of you get? Nothing. Okay, that's why 0 divided by anything is 0. I could share it with all of you. You guys can all have some of my nothing.
Yeah.
You're welcome. Okay? All right. Let's move on. Once we know the axis of symmetry, we also know one of these values. Which of the values do we know? X. So this is 0, which tells us now where to start in our table. We're starting our table at x equals 0 in the vertex, in the middle of the table, because we're going to make it symmetrical. So when I put 0 in for x, 0 squared is 0. We get 0 out. So that means the other point on my vertex is 0. It gives me the order pair 0, 0. I could pick a value here like 1 and 2 and negative 1 and negative 2. And we put these in. So we go 1 squared is 1. 2 squared, 4. Negative 1 squared, 1. Negative 2 squared, 4. I want everyone to put negative 2 squared on your calculator. Make sure it's 4. Go for it. Calculator. Yes, how many of you got positive 4? How many got negative 4? Now, the reason is, if I go negative 4 and I square it, I get, not 9. Let's try this again. Negative 4 and I square it, I get negative 16. Was it negative 2? I'm sorry. Okay, let's try that again. Negative 2 and squared, I get negative 4. Now, Declan, what's the problem?
Well, if you put negative 2 in parentheses, you get 4.
Good, then you get positive 4, right?
No? You put the negative 2 in parentheses and
oh.
then the square on it.
Oh, so put the parentheses, negative 2, square it, and then parentheses?
No. But you put the square on the outside.
Oh, okay. So let's delete that. Delete, and then put the squared out here.
There you go.
Okay, and we get 4. Good? Just like we see right here. Why? Because here it's saying negative 2 times negative 2. Here it's saying, the top one's saying 2 times 2 times negative 1. Okay?
Why?
Because when you don't put something in parentheses, you're saying that squared, you're squaring this part and then multiplying by that value. Okay? So we want to make sure you get those parentheses in there and then graph it up. Okay? Mr. Rosenbaum. That graph? Oh. All right. Here we go. Not this one. Okay, so we've got a graph here. Got it? Note that, make sure that we get a nice little, can I draw on this?
Yeah.
Okay, make sure we get a nice little curve here. Okay? I think we may have missed a point. So 1, 4. I think we're 2, 4 should be there. And there. Okay? So I'm going to let you fix that in pencil. Okay, borrow yours?
You want that little curve?
No. Yeah, you want that little curve.
Oh.
Okay? Dude. All right. Get your notes back. There we go. So we got 1, 1, 2, 4. Get that little curve. You don't want it to be a point. You want to be a cup at the bottom. Our vertex, that's called a maximum or minimum. That's a minimum. Questions there? Everyone try number 2. Give number 2 a go. Okay, A is 1, B is 0, C is 5. Opposite of B over 2A. Negative B over 2A. That gives me negative 0 again over 2 times 1 or 0. So x equals 0. We get 0, and when we plug this in, we get x squared plus 5. That gives us 0 squared plus 5. This is 5. It was 0 a minute ago, right? Okay? But now it's 5. It's 5 more than before because we took our original x squared, and now we're just adding 5 to each of those values. So when we had 1 before, well, x squared was 1 squared, or 1, and now we add 5 to it. So we get 6. Okay? And then 2 squared, that's 4. 4 plus 5 is 9. Now, should I have to calculate these up here?
You put 4 on the outside.
Oh, should have been 2. Thank you. Hey, remember, it's symmetrical. So if you're 1 unit away this way, go 1 unit this way, it should be the same value. It's symmetrical. Negative 2, 2 units away from the axis of symmetry. The vertex there, same thing here. 9 there. Okay? So when we graph it, we're there, and there, and there. Make sure that it's curved at the bottom. Okay, you have that parabola there. Put your arrows on the end and you got it. What? Hey, what happened to our graph here? It went up. How many units? 5 units. Where did that 5 come from? The C term. The C term moves your graph up and down. In fact, your C term, the C term is always the y-intercept. It just so happens right now the y-intercept is the vertex because there's no v, or no b term. Okay, but our C term is always the y-intercept. So when we said one of our goals today is figure out what C does, that's what C does. C moves it up and down, moves our graph up and down. It's always your y-intercept. For today, our y-intercept happens to be our vertex because we don't have a B, so it's not moving left or right. B moves it left and right, which we do tomorrow. Okay? I want you to graph number 3 now, please. Number 3 looks very similar to number 2. Give it a go. I've started filling this out. Notice when we get here and you figure, you put this in, you got negative x squared plus 5. Okay, and we put our 0 in, plus 5. That still gives us 0 or 5 there. But when we put our negative 1 or positive 1 in, this negative is still on the outside. Okay, and we put the 2 in, that negative is still on the outside. So when we input it into our calculators, that should be a 1. We input it into our calculators, we've got to input it just like this. Okay? Still have that. That's a negative inside now. Negative and plus 5, so negative 2. Okay? Our graph ends up being upside down. What made it turn upside down?
Negative A.
Good. If A is negative, the graph is flipped upside down. If A is positive, the graph is right side up. Your goal is to finish this packet and see what else A does. Okay? A controls one other thing you're going to figure out when you finish this packet today. Yes?
I don't get how.
Hey, when you fill out number 4, you'll be able to kind of see what else A controls. Finish the packet, but after you finish 4 and number 7, which changes your A term, you should be able to complete these 2 statements. That's your goal tonight. Okay?
Do you want us to write them down or just
I would write them down. For quick hint on number 7, as soon as you figure out this is 0, if you have a denominator, always go up by that denominator. So count up by 2s. It'll make your numbers on this side become whole numbers.